Okay, so I'm going to talk about the topic of the canyon hypothesis. And the canyon hypothesis has to do with why some viruses are resistant to host immunity and what types of methods they use to acquire this immunity. So, one explanation for the relative resistance of viruses is the canyon hypothesis. So, there's an attachment site that antibodies use when they are trying to locate a pathogen. And it's possible that this attachment site is located deep within narrow crevices or canyons on the surface of a virus. So, for example, this has been seen in the structure of human rhinovirus 14, and I'll show how that looks. So, human rhinovirus has this symmetrical structure. It looks a little something like this. And it's a 12-fold structure. It has 5-fold vertices, and there's 12 of those 5-fold vertices. So it's got these little pentagon shapes. This isn't drawn perfectly to scale, but it has these shapes all over the surface of the capsid of the virus. And inside each of these little pentagon shapes is a canyon. So overall, kind of looks like that. You see little canyons in each of the 5-fold vertices. So that's H, and this is human rhinovirus 14. So a bit more of a close-up look. Looks kind of like this. You have the canyons. So here's a canyon, and here's one right next to it. So when you have these canyons, the virus uses the canyon to attach to, say, a membrane protein in the host cell's membrane. So there's a membrane protein, and here is the lipid bilayer. And yeah, get the gist of that. So as you can see, the membrane protein fits in the canyon just fine. It goes all the way down to the bottom of the canyon, which is what is needed. So these little residues at the bottom of the canyon are what is the most important for recognizing the virus. And the virus wants the receptor on its host cell to recognize it so that it can attach and infect the cell. However, if the virus is attacked by an antibody, it looks like this. Here's the Fab region. Here's another Fab region. And there's the rest of the antibody back that way. Okay, so this is a Fab region. Just going to put F for Fab. And as you can see, this Fab region is too big to fit inside the canyon. It wants to get down to these residues at the bottom so it can recognize the virus as a pathogen and bind to these antigens presented by the virus so it can take further action to eliminate the virus. But since it is too bulky to fit inside there, it's only going to react with these residues on the outside of the canyon. And these residues on the outside are highly variable, and they mutate a lot. But even though they mutate quite a lot, they are not necessary to the function of the virus. Okay, so overall, the virus is able to do what it needs to do. It is able to attach to this membrane protein in the host cell, and it's able to infect the cell. However, if the host cell's immune system tries to attack it, it doesn't fit down into the canyon where it needs to be to attach to the antigens presented by the virus. So the virus is basically hidden from the host cell's immune system. And obviously this is very beneficial for the virus because it enables it to be more virulent and infect the cell for a longer period of time. So this is a very plausible hypothesis, the canyon hypothesis. It's not only been seen in the human rhinovirus, but it's also been seen in human immunodeficiency virus, or HIV. And another reason why this is a plausible hypothesis is that you see these canyons, like I just drew, in most viruses that infect cells that have immune systems. However, if the cell doesn't have an immune system, the virus is going to look more smooth, kind of like this. It's not going to have any canyons. So that shows that if a virus has a canyon, or has multiple canyons, that it has something to do with antibodies in the host cell. So, as this is starting to become an even more reasonable explanation for viral immunity to antibodies, it's very important to keep studying the canyon hypothesis, as it can be used in the development of different drugs. If researchers can figure out how to adapt the shape of the canyons, so adapting this shape right down here, then it would possibly make it very difficult for the virus to attach to its host cell. So what you want to do is adapt the shape of the canyon, or just adapt the canyon in general. And once this happens, it could also neutralize the virus by using the antibody. So adapting these canyons can possibly make the antibodies more effective. So if the canyon was wider, then the antibody could fit down in there and neutralize the virus. So that's basically all for the canyon hypothesis, and thank you for listening.